Hello and welcome back. In this episode we're going to take a look at the ListView widget, which allows you to create a scrolling list of children. Our homepage contains a scaffold with an app bar, and inside the body of the scaffold we're going to create a list view. Now the list view accepts a list of children, and for the purposes of this demonstration we will create 3 containers. The first one being a red container with a fixed width and height of 100 apiece, and we just copy and paste that a couple of times to create a green container and a blue container. If we save that, you'll notice on this right hand side we have a list view with our red, green and blue containers. You'll notice this looks similar to when we had a column with children. However, by default the list view will stretch its children in the cross axes. This is different to a column, which by default will centre align its children in the cross axes. You'll notice this is why, even though the containers contain a width of 100, the list view will stretch the containers to be as wide as the cross axes allows. Because the list view by default is vertical from top to bottom, that means the cross axis is horizontal from left to right, meaning that the children of the list view will be stretched along the width. You'll notice when we scroll up and down we get some animations there, feedback at the top and bottom to show that the list is scrollable. Again, this is different to a column or a row, where if you attempt to scroll up and down, there will be no effect. There are a few other parameters that you can specify when creating a list view, and the first we're going to look at is the scroll direction. Now, the scroll direction allows you to customize whether the list should be scrolling vertically, up and down, or horizontally, left and right. By default, list views scroll vertically from top to bottom. However, you can change this by specifying a scroll direction of axis.horizontal, and you'll notice we then have a list view which scrolls from left to right, like so. If we remove that, go back to the default vertical orientation, you'll notice there's a parameter called reverse. Reverse essentially is false by default. However, if you specify a reverse of true, you'll notice the children inside the list view have their ordering reversed, and you'll also notice how they then appear at the bottom of the list. The red container, rather than being the first at the top, becomes the last at the bottom, and essentially the entire ordering of the list then becomes reversed. Another property is the shrink wrap property. Now, by default, a list view will be as wide and as tall as its parent widget allows, the parent widget of the list view being the scaffold's body. You'll notice how these scrolling animations occur at the top and the bottom of the scaffold body. However, if we specify a shrink wrap of true, then the scrolling animations will move to the top and the bottom of the containers. Essentially, shrink wrap means that the height of the list view is determined by the total height of the children, 100 plus 100 plus 100, giving a total height for the list view of 300. Essentially, therefore, with a shrink wrap of false, the list view will expand to fill its parent's height, whereas with a shrink wrap of true, the list view's height will be determined by the total height of all of the children added together. Removing the shrink wrap there, you'll notice the height reverts to be the full height of the scaffold body. The padding property can be used to control the padding of the children inside the list view. For example, if you wanted to pad all of these containers by 16 pixels, then you could specify padding with edgeInsets.all, specify a value of 16. You'll notice how the child containers are then padded by 16 on each side. However, there's a key difference here between specifying the padding on the list view and wrapping the list view in a padding widget. You'll notice how, when I go to scroll the list view itself still takes up that full width and height of the parent body, only applying padding to the children inside the list view. However, if we remove the padding there and wrap the list view with a padding widget, specifying the same padding there of 16, you'll notice the children, again, are padded by 16. However, the entire list view is padded. You'll notice when I go to scroll up and down how the scrolling feedback there at the top and bottom, the animation if you like, is also padded by 16. This is a fairly key difference to note. If you only want to specify padding of the children inside the list view, then you should use the list view's padding parameter, like so. However, if you want to apply padding to the entire list view itself, as we can see here running in the Android emulator, then you can simply wrap the list view in a padding widget, as you would with any other widget. A key difference there to note between the two different types of padding that you can apply to a list view. Last but not least, we'll have a look at the item extent parameter. The item extent parameter allows you to manually specify the height if the list view scrolls vertically, or the width if the list view scrolls horizontally, of each of the children. You'll notice that the child containers are given a fixed width and height of 100. However, what we could do, rather than specifying this on each of the child containers, we could specify an item extent of 100 on the list view, and this will essentially give each of the child 100 height, with the containers by default of course filling the width and height they have available to them. You'll notice if we specify an item extent of 200, how each of the children inside the list view grows to be 200 high. Specifying a scroll direction of horizontal, you'll notice how the child containers then become 200 wide, because the scroll direction is horizontal from left to right. Essentially, therefore, the item extent allowing you to specify a fixed height if the list view scrolls vertically, or a fixed width if the list view scrolls horizontally, to give to each one of the children inside the list view. That's a look at the default ListView constructor, and you'll notice there how the containers without an item extent or without a fixed width and height disappear from the application. That's because by default the containers will fill the height of the parent if the height is unconstrained. However, because the list view scrolls infinitely vertically, the containers will grow as small as possible in the vertical axes, giving each container here a height of 0. You can find more about this in the episode covering containers. Now, the list view does not just come with a default constructor, it also comes with a selection of named constructors, notably custom, builder and separated. The custom named constructor allows you to specify a slivered child delegate to customize how the list view children should be rendered. We'll take a look first of all at the ListView.Builder named constructor. The ListView.Builder constructor takes an item builder which is used to build each of the children in the list view. This is different to the default constructor, which takes in a list of children specified ahead of time, with the item builder callback here being called by the list view to render each of the children individually. For the purposes of this demonstration, we will create a list view that scrolls through each of the material primary colours. The item builder callback function specifies a build context and also an index, the current index of the child inside the list, and it expects you to return a widget. In this case, we're going to return a container, as earlier, and we're going to specify a colour of colours dot primaries, and we use the index there to get the particular colour at the current index. We'll also give the container a fixed width and height of 100. Likewise, the ListView.Builder also allows you to specify the item count. This essentially is the number of children that are to appear inside the list view. This will be colours.primaries.length, essentially the number of colours that are in the array of primary colours from the material colours. Essentially, you'll notice here now how the list view dynamically builds for each one of the primary colours, essentially calling the item builder callback function with a build context and an index starting at 0, and we then return a container widget, but this could be any widget, and the container widget is a colour of the material colour at the current index with a fixed width and height of 100. So essentially you'll notice how we start at index 0 with the colour red, then move on to colour pink, purple, and so on, moving all the way down to the bottom of the list to this slate colour. Essentially, the ListView.Builder allows you to dynamically build each of the children inside the list view rather than having to create them all one by one using the default ListView constructor and the children parameter. This is incredibly useful if you have a potentially large or indeed infinite amount of data to be displayed in your list view. For example, if you make a call to an API which returns a large volume of data. The ListView.Builder will call the item builder callback for each of the children that appear on the screen, and also a few children before and after to allow for smooth scrolling. Because the item builder callback function is called dynamically, this essentially means that it is only called for children that are currently displayed on the screen and a few before and after, meaning that if you have a list length of potentially infinite, the ListView.Builder will only build the children that will appear on the screen and those slightly before and after, meaning that your list view can go on infinitely whilst only displaying a small number of children at any one time. Likewise, these children are then disposed when they are removed from the screen and are rebuilt if they then reappear on the screen. Essentially, this allows you to have an infinitely scrolling list whilst still retaining superb performance even on low-end devices. Essentially then, the ListView.Builder allowing you to specify a custom item builder callback and an item count, the number of items to be displayed in the list. However, you might be wondering, how would you display a separator between each of these children? And that is where the ListView.Separated named constructor comes into effect. Much like the builder named constructor, the separated named constructor takes an item builder, an item count. However, it also takes a separator builder, which is used to build a widget to separate each one of the items. Essentially, we can specify a separator builder. This is a callback function, much the same as item builder, taking a build context and an index of the current position in the list, and this once again expects you to return a widget, which for the purposes of this demonstration will be a simple divider widget. However, you could specify any other widget to suit your requirements. If we now save this, you'll notice how we have a divider now between each of the list view's children. Now you can of course get clever and use the index provided to only build a divider on certain indexes. For example, if you only want each second container to be divided, then what we can do is we can specify if the index plus 1, remembering that the index starts at 0, with a modulus of 2 equals 0, then return a divider, and if not, just return an empty container. Essentially what this is saying is, if the index divided by 2 gives a remainder of 0, then return a divider, otherwise return a container. If we save this, you'll notice how we have the first 2 children, then the divider, then the second lot of 2 children, and then a divider, and so on and so forth, down to the bottom of the list view. Essentially, therefore, you can use the index provided to create some custom logic to determine when to and when not to display a separator between each of the items. So essentially you have there the 3 different constructors you can use for the list view: the default constructor, the builder constructor, or the separated constructor. Or if you want complete fine-grained control, you can use the custom constructor to fully customize the behavior of the list view. Essentially you can use the separated constructor, much like the builder constructor, to specify an item builder callback and an item count, and also a separator builder callback to separate each one of the items, or separate the items based on some custom logic, as we have done in this case. You can use the ListView.Builder named constructor to simply specify an item builder and an item count. This is ideal if you have lots of data to be displayed in a list, or potentially an infinite amount of data, because the item builder callback will only be called for those children that are displayed inside the screen and those just before and just after, to allow for a completely smooth, fluid scrolling experience. Finally, if your list view has a small number of children, or if you create those children ahead of time before creating the list view widget, then you can specify list view with a default constructor and fill in the children parameter to be the children inside the list view. Essentially then, separated to be used if you wish to separate the items built using the item builder, builder if you want to be able to build a large list using said item builder, and finally the default constructor if you have a small number of items, or if the items are built ahead of time before the list view is built. I hope you found this useful. Thank you very much for watching.